Hi, and welcome to today's lesson. We're going to be going over solving linear equations in one variable. Linear equations come in the following form. Ax plus b equals c. So some examples of linear equations are like 3x plus 5 equals 7. Another example of a linear equation is 2c minus 5 equals 7. In this case, we're just using c as our variable instead of x. Another example of a linear equation is something like 42y plus the square root of 3 equals 99. Some examples of equations that are not linear would be something like 2x plus 2y equals 10. In this case, we have two variables. So here we have x and y. So this would not be a linear equation in one variable. Another equation that's not linear would be something like 2x squared plus 3 equals 5. In this case, this is a quadratic equation. All right, anytime you get a polynomial with an exponent of 2, you get a quadratic equation. Now, in previous classes, you might have been asked to do something like this, where you have an equation and you're given an x and you're asked to plug in and evaluate. So in this case, we have 2x plus 3 equals 9, and we're given x equals 3. So all we have to do is plug in 3 and see if the equation is true. So on the left side, we have 2 times 3, which is 6. 6 plus 3 is 9. And on the right side, we have 9. 9 equals 9. Therefore, this equation would be true. If instead you were given something like x equals 4, well, let's see. 2 times 4 plus 3 equals 9. Well, 2 times 4 is 8. 8 plus 3 is 11. And 11 does not equal 9. Therefore, this would be a false situation. Before we move on, I need to go over two very important properties of equations. So the first one is going to be the addition property of equality. The addition property of equality basically just says whenever you add or subtract a number to one side of the equation, you must also do it to the other side of the equation. So here we have the same equation from previously, 2x plus 3 equals 9. I'm going to add 3 to both sides and see if we get a true equation. So when we do that, we get 2x plus 6 equals 9. Sorry, not 9. 9 plus 3 is 12. And we know x equals 3. So I'm going to plug in 3 for x. Two times 3 is 6. 6 plus 6 is 12. And 12 equals 12. Therefore, this equation is true. So that's what the addition property of equality is. Whatever you add or subtract to one side, you must also add or subtract to the other side to maintain equality. The second property that you need to know is called the multiplication property of equality. And this just says whatever you multiply, divide on one side of the equation, you must also do to the other side of the equation to maintain equality. So I'm going to try multiplying both sides by 2 and see if we still end up with a true equation. So 2 times 2x plus 3, it's going to be, 4x plus 6 equals 18. And again, we know that x equals 3, so we're going to plug in 3 for x. So on the left side, 4 times 3 is 12. 12 plus 6 is 18. And 18 does equal 18 on the right side. Therefore, this is a true equation. So these two would be the two properties that you would need to know to help you solve for the unknown in linear equations. So let's go back to our previous problem, which again is 2x plus 3 equals 9, and we are asked to solve for x. Your goal in this case would be to isolate, okay, in order to solve linear equations in one variable, your goal is to isolate x to one side and have everything else on the other side. So what you end up with is x equals something. We don't know what that thing is, but we're going to figure it out. So this is the situation you want. You want to manipulate this linear equation so that you have x on one side and our answer on the other side of that equation sign. In order to do that, you want to isolate the x variable, and you want to move everything else to the other side. So we want to move this plus 3 to the other side of the equation. Okay? So let me erase this real quick. So in order to do that, in order to have x on one side and everything else on the other side, we need to do what are called inverse operations. Inverse operations are just doing the opposite of whatever is being done to the x. So let's say we have something like plus 5. Well, the opposite of adding 5 would be subtracting 5. Okay? The opposite of subtracting 5 would be adding 5. If we had something like multiply, if we had x being multiplied by 5, well, the opposite of multiplication is division. So the inverse of multiplying by 5 would be dividing by 5, and vice versa. So dividing by 5, the inverse of dividing by 5 would be multiplying by 5. Okay? And that's what we're going to do here. Again, we want to isolate x on one side and have everything else on the other side. To do that, we want to use inverse operations. So I want to move this positive 3 to the other side. To do that, we do the opposite of adding 3, which is to subtract 3. So I'm going to subtract 3 from both sides. If you remember what we just went over, we are using the addition property of equality. Okay? So when we subtract or add something from the left side, we also have to do it to the other side. So positive 3 and negative 3 are going to cancel out. So we end up with 2x on the left side, and then 9 minus 3 is going to be 6. So 6 on the right side. Now here you can see that x is being multiplied by 2. Well, what's the inverse of multiplying by 2? The inverse of multiplying by 2 is dividing by 2. So let's do that. We're going to divide 2 on both sides. So when we divide 2x by 2, we get x on the left side. And then 6 divided by 2 is 3. Therefore, x equals 3 is our answer. And one thing you want to get in the habit of doing is checking your answer. So we can check by simply plugging in 3 into our original equation. So 2 times 3 plus 3 gives us 9, right? 3 times 2 is 6. 6 plus 3 is 9. And that's how we know we did this problem correctly. Let's try another example. Here we have negative 2x minus 1 equals x plus 14. Now I'm going to give you a couple seconds to pause the video and figure this out on your own if you know how to do it. Okay, so just like the previous problem, what we want to do is isolate x on one side and to have everything else on the other side, okay? What I mean by having everything else on the other side is to move the constants to the opposite side of where x is. So in this case, I want x on the left side. So I want x equals something. All right. So I want x on the left side and then all the constants, whatever is on the left side to the right side. So in order to do that, I can do that by subtracting x from both sides. And I can also move the -1 to the right side by adding 1 to both sides, right? All we're doing is inverse operations. Here we have a positive x, so we're subtracting x, both sides. Here we have -1, so we're the opposite of subtracting 1 is adding 1, so we're adding 1 to both sides. We're going to do this simultaneously. When we do that, the x's here will cancel, and we can get rid of the 1. On the left side, we have -2x and -x. When you combine -2x and -x, you get -3x equals 14 plus 1 is 15. And as you can see, we have -3 multiplying x. The opposite of multiplying by -3 is dividing by 3. So we're going to divide both sides by -3. The -3's will cancel. So on the left side, we have our x. This is exactly what we wanted. Just our x by itself on the left side. And then on the right side, we have 15 divided by -3, which is -5. And that is our answer. Again, you want to get in the habit of checking your answers. So we're going to plug in -5 into our original equation to see if we did this correctly. So here's the left side. We have -2 times -5 minus 1. And on the right side, we have -5 plus 14. All we're doing is plugging in -5 into our original equation to see if we did it correctly. So -2 times -5 is 10, right? Negative times negative is positive. So we have 10 minus 1, which is 9 on the left side. And then -5 and positive 14 is also going to be 9. Therefore, our answer is correct. Let's try one last example. Here we have 12 minus 11 times the quantity of x plus 11 equals -8 times the quantity of x plus 11. Again, I'm going to give you guys a couple seconds to pause the video and see if you can solve this on your own. Okay, so let's go ahead and solve this. Now, one important skill to have when you're solving for the unknown in a linear equation with one variables is to simplify what can be simplified before you even start solving for the unknown. So in this case, what you can see is we have a parentheses. And if you remember from Algebra 1, what you can do, or pre-algebra, what you can do in this case is to distribute the -1 to each element in the parentheses to simplify. So let's go ahead and do that. On the left side, so we have 12. When we distribute the -11, we get -11x. -11 times a positive 11 is going to be -121. And on the right side, when we distribute, we get -8x. So all we're doing is multiplying. And -8 times a positive 11 is going to be -88. Okay. And one thing you can notice, again, is we can further simplify, right? Because we have 12 and -121 on the left side. Okay, so when we simplify the left side, we get negative 11x minus 109, right? 121, negative 121 and positive 12 is going to be a negative 109. And the right side remains the same. All right. So now that we have both sides simplified, we can finally begin to solve for x. Again, we want x on one side. So I want x on the left side of the equation, and I want everything else on the opposite side of the equation. In order to do that, we're going to use inverse operations. So we can get rid of this negative x by adding 8x to both sides. And we can also get rid of this negative 109 by adding 109 to both sides. When we do that, the 109s will cancel, the 8x will cancel. On the left side, we have negative 11x and positive 8x. When we combine those like terms, we get negative 3x. So one thing you need to know or have mastered by now is combining like terms. If you don't know how to combine like terms, you're going to have trouble solving for the unknown variables in this case. So on the left side, we have negative 3x. On the right side, we have negative 88 and positive 109, which is going to be 21, right? 109 minus 88. Sorry. 9 minus 8 is 1. 10 minus 8 is 2. Yeah. So on the left side, we have negative 3x. And on the right side, we have 21. The inverse operation of multiplying by negative 3 is to divide by 3. So let's do that. We're going to divide both sides by negative 3. And when we do that, we are left with x. Just x by itself. This is exactly what we wanted. 21 divided by negative 3 is negative 7. Okay? And that should be our answer. And I'll leave it up to you to check the answer by plugging in negative 7 into the original equation and see if we did this correctly. Now, I'm a firm believer that math is one of those subjects you can only learn by doing. So for those who truly want to learn the subject, there's a link to practice problems in the description, which I highly recommend that you do. Thank you for staying with me, and I'll see you next time.